Hello, this is Walker Physics, Chapter 7 on work and kinetic energy, and we're in the end of the chapter, question number 31. A block of mass m and speed v collides with a spring, compressing at a distance of x. What is the compression of the spring if the force constant of the spring is increased by a factor of 4? This is a cool question. This is using two different things. We're looking at work. And work, remember, since they're giving you a velocity and a mass, equals 1/2 mv squared. We're also looking at the Hooke's law, and Hooke's law, remember, is work equals 1/2 kx squared. And x is the distance that you compress a spring, or you stretch the spring. K is the constant, how stiff that spring is. And so you're going to see that these two are absolutely related to each other. Okay, so since the work is going to be the same, you set the work equal to themselves, you're going to have them equal to each other. So 1/2 mv squared equals 1/2 kx squared. Well, the 1/2s cancel, and you're going to have mv squared equals kx squared. And you are wanting to know if I make it 4 times stiffer, okay, so I'm increasing k by 4 times, then what is going to happen to x? So let's solve for x. Well, x will be the square root of mv squared over k. So what happens if I increase k by 4 times? I'm making it 4k. Right, so what's going to happen to x? So if I go here, 4k, I can pull out the 4. Okay, so because you can do the square root of the top divided by square root of bottom. The square root of 4 on the bottom is 2 on the bottom, which will equal 1/2 times the square root of mv squared over k. Well, you already know that mv squared over k equals x. So this is going to be 1/2 x. So what will happen is if you make it 4 times stiffer, it'll travel half as far. Okay, so you have a block, and that block has a speed, and so it's going to have a kinetic energy. There's energy into that moving block. It slams into a spring. The spring is stiff or not stiff, and that block that's moving makes the spring go in. If you make it 4 times bigger, you are going to make 4 times stiffer. If you make the spring 4 times stiffer, you won't go in as far because the spring is going to resist that motion. Okay? And because the distance is in square, then as you increase the k, you are only increasing the x, or you're only going half into the x. You're only moving half the distance that you did when the spring was not as stiff. Okay? I like this problem.